This week we continue with a discussion on climate and now looking at approaches to potential solutions. And then the topic of water. We're now module 5. And so we're looking now at climate with our strategies to address the climate challenge. If you look on page 78, you can notice the United Nations Convention Framework on Climate Change, the UNFCCC. This was the first kind of setup to address internationally the climate change issue, and the United Nations became the forum out of which proposals and policies internationally and treaties have developed. It was first formulated at the Rio Conference in 1992. I think the first real conference that, where there was a real awareness of that. I remember President Bush Sr. was part of that, or involved with it, address climate change as a real issue. It was followed by Kyoto in 1997. The U.S. was not a signatory of that. But the big one, and you had others like the Copenhagen in 2010, but the biggest one was in Paris Concord in 2015. And here the nations committed to temperature levels at or below the 2 degrees Celsius above pre-industrial levels, which would have been the amount of temperature and then concomitant carbon dioxide that would be circa 1712. So if we could get no more than 2 degrees Celsius, which was about 3.5 degrees Fahrenheit, and to strive for a more ambitious target of 1.5 degrees Celsius level above pre-industrial. The Paris Concord further pledged to have zero carbon emissions by the end of the century and engage in review every 5 years, beginning in the year 2023. And this is the first conference where you don't have the developing nations pitted against the industrialized nations. Everybody was ambitious target, but everybody could set their own target. And so almost all the countries bought into it. I think Nicaragua didn't, or whatever. But this is the first conference where nearly all the countries of the world were on the same page, including China and India, as well as the United States. This was very much the legacies of the former President Obama. However, President Trump, one of the first actions he did was in spring of, or the June, I think, of 2017, was formally withdraw U.S. participation. And so these are some of the world leaders who participated. They were like a who's who around the world. And you can see then former President Obama on the middle there. You see also Young Climate Justice demonstrators at Paris Climate Summit B. So this is very active around the world. So there's a couple of approaches. How do we get climate stabilization? One term is called climate neutral. And this means living or doing business in a way that results in an overall net climate impact of zero. ASHE, the American Association of Sustainability in Higher Education, and the Franciscan Climate Pledge are examples of that. Commit yourselves to be climate neutral. And Madonna of the Franciscan Climate Pledge is a signatory of that one. Carbon neutral is living or doing business in which there are no net greenhouse gas emissions. So it's not that much different. One looks at the emissions of greenhouse gas, one looks at total climate. So the problem with carbon neutral if you get too narrow focus on that, you can overlook other greenhouse gases in addition to CO2 in the formulation of how you're going to get there. So what are some steps for climate action plans? And there's 4 of them, as your text makes known on page 79. You make a plan, you measure, which you prepare a greenhouse gas inventory, which that is done on the right-hand side. It will talk about that when we get into energy, and especially Energy Star. Reduce emissions and offset any remaining emissions, and kind of talk about what that means. So first of all, make a plan. What are the boundaries of the plan? How much of the organization is included? You know, what's the scope of this? Who's got to buy in? Who's responsible? What kind of emissions will be the focus of the plan? Just carbon dioxide, nitric oxide as well, other pollutants, particulates? And will the emissions, so therefore the scope, will the emissions be strictly within the organization, or will we look at indirect use beyond the organization, like upstream or transportation outside among our employees or our partners? And so you determine then who's going to be involved in the planning process, who's going to be the leader, who are the party. You get a group of people, either outside consultants and or in-house. When Ford Motor makes their their inventory, they have the resources to set up shop within. And then make sure every step is in writing, so everything's transparent and accountable. So we look at the step 2 is measure, and you look at to what extent is your organizational reach in terms of what emissions you're going to look at and try to reduce. If you just scope 1 would be focuses on emissions that are owned by or controlled by the organization. Then expand that. Scope 2 would include emissions from purchased electricity or purchased heat, that you're taking in, whether it's a school or an industry or whatever. Scope 3 would include indirect emissions from other sources, such as vehicles owned by others and used to transport people or goods, the extraction and production of resources purchased by the organization, and reduction in emissions and the end use of the product sold. Okay, what kind of packaging or whatever, how do we deliver that to places to reduce our carbon footprint? Now, according to the Greenhouse Gas Protocol, which kind of sets this forward, Scope 1 and Scope 2 should always be incorporated into a reduction plan. Scope 3, however, is optional. So here's more about measure in particular. You collect data from several sources on emissions associated with the organization. You calculate. Tools are available for this step. And I'm going to talk about calculate when we get to Energy Star again and the portfolio management database system in a few weeks. We'll revisit this. Quality control. You have a third party check the data and the methodology of collection to ensure integrity of the process. And you have regular evaluation of the progress. And as I mentioned, EPA Energy Star Portfolio Management Database System does that. And we'll walk you through with that when we talk about Energy Star again. So, to reduce emissions, this other part, that's number 3. So, low-hanging fruit, and then symbolically powerful approaches. So one thing is to change your behavior, educate the staff, turn out the lights if you're going to be gone 10 minutes, set the temperature down when you leave or whatever, those kinds of things. Energy efficiency, maximize your payback or return on investment. So payback is like how many years when you have an investment of something, like say, remember when you went from incandescent to complex fluorescent light, it burned like 30% of the electricity. So the payback was in less than a year. I think it was like 8 months. And so the return on an investment would be like I think it was 80, more, it was more than 100%. 100% is is like how much you recoup within a year. So there's other things that you use pilot project. You can work out the kinks, like a demonstration center. I remember they've since closed, but the famous one in Southeast Michigan was the Upland Hills Ecological Awareness Center out in Oxford, where they built underground building, education things. They had heat and, like very simple technologies, but reduced like in energy, reduced greenhouse gases. They had a big old wind turbine, and famous designer Buckminster Fuller, I think, helped them with that. Now, there's symbolically powerful approaches. Like, for instance, you put in an on-site renewable system for publicity. In my case, I did that. I reduced our peak energy demand 60% in 5 years. So we're saving a lot of money in my church by energy efficient measures. And after 5 years of that, then I put on a wind turbine and solar panels, photovoltaics, on top of my rectory roof. And that was symbolically powerful because this was in a working class neighborhood of an inner ring suburb of Detroit in a little church. And so I was shocked at the attention we got from the New York Times, CBS Sunday Morning News, Rolling Stone. I think I mentioned all those before, but the thing had legs. And I said even Channel 4, Great Britain, came over and wanted to do a special on this. And Today's Show came, although that got on the cutting room floor. So the combination then is to use money saved from energy efficiency measures to finance on-site renewables. So again, these are symbolic because they're very visible. Even though you might say, well, energy efficiency is going to save you the most money and reduce the most. That's without saying. But if you want to get public attention, sometimes you do these demonstration things, which are very visible, like a wind turbine on your site. There are some energy strategies. Like, again, energy efficiency, it reduces demand. And they said the demand side and supply side. Demand side is needing less energy, less fossil fuel to begin with. The supply side is or generation side rather, supply is that you produce then replacement electricity from renewable resources. So you switch, and the other thing you do is switching, which brings us to this one, switching to less polluting source. Now, for instance, you go from a coal-fired power plant to plants that run on natural gas. They're still producing greenhouse gases, but the greenhouse gases they're producing is much less, so it's a transition fuel. Just as I was saying that if you go from incandescent light to complex fluorescent light, then to LED light, complex fluorescent lights are like a transition lighting source. So put out again on-site renewables, or you purchase renewable energy credits, RECs. They're also known as green certificates. For instance, the Native Energy is one of them, which I used to help support native wind farms. I was trying to be neutral, carbon neutral, and I still was. I did all these calculations one year when I went to a hybrid, and I was doing all these on-site renewables, energy efficiency, but I, had local farmers market, but it was still way too much. And I said, how could I be somewhat carbon neutral? So last part was purchasing offsets, green certificates, or we'll see later. So transportation, that's one way you can reduce emissions in this area. Reduce air travel. You switch to trains or other sources of transportation, such as buses, your text well points out. When flight becomes necessary, then avoid night flights. There's a significant reduction, as your text points out, because of the contrails and what they capture flying at night. Not flying at night, flying during the day. Definitely going to work, carpooling. They now have, a lot of places have carpool lanes, or electric cars. We're switching over there, or plug-in hybrids. And so there's the technologies changing. A few years ago, it was like the chicken or the egg. Was it, if you have a plug-in hybrid or electric car, how are you going to charge it? There were no charging stations. Now, actually, right near Madonna's campus, there is a company that makes charging stations for this burgeoning electric car market. And of course, bike and walk when feasible. It's a big one. I forgot to mention that. Where people conference instead of going to meetings, they can go to meeting.com, Skype, that kind of thing. Reduce emissions in terms of buildings. Buildings account for 39% of greenhouse gas emissions in the United States. It's not in your text, but it's another source I got. New construction techniques can result in zero energy buildings. And you can see an example in that picture on the right. There's strong insulation such as integrated concrete form foundations, ICF, structured insulated panels. I went to a workshop that in West Virginia some years ago just to learn it, maybe for my own future. Renewable energy generation, etc. So that using geothermal, geoexchange, we get to energy. We'll talk about that. Ground source heat pumps. And operations and purchasing. You schedule maintenance on your, HVAC systems. Heating maintenance. Heating and cooling systems. You switched. And I also say too is one thing you can do and purchase HVAC is later we'll call it combined heat and power, but talk about that when we get to energy. You can switch to recycled and double-sided paper. Carbon release and paper making process is quite intense. My cousin lives in Manistee, and there's this old paper mill that's really spews out the greenhouse gases. The use of recycled material requires fewer raw materials. There's a great recycling place when first in Madonna was near Henry Ford Hospital, and recycling, and then they also had things where to make compostable products like for eating now, so it's become much more popular. Use of recycled material, another positive benefit is that it reduces the methane gas emissions that emanate out of landfills. So you can see that's a recycle. I think that I was trying to get from Recycle Ann Arbor, but you see a recycling center there. And in terms of strategies in forests, farms, and soil, forests are carbon sinks. It's necessary to reduce or eliminate the clear-cut approach. There's so much of that was done with just cut everything. So now there's strategic, sustainable forest practices where you just target individual trees that need it. And as much as 15% of carbon emissions come from deforestation. Someone says the Amazon, the rainforest, the Amazon's the Earth's lungs because it absorbs all that carbon. Which means each acre of tropical forest sequesters as much carbon as the carbon emitted by driving a car 500,000 miles. So there's power of that. And one thing is biochar. I've actually read a book on that because it's really interesting. This stuff is a powerful carbon stabilizer. You burn the wood at low temperature without oxygen, and it pulls the carbon. So there it is. It'll actually pull the carbon out of the air when you use that, and it'll also increase soil fertility. So if you use it on farms and and this is an ancient technique, agricultural technique, biochar. Okay. You can see it on the right there. There's some biochar that someone's holding. Another strategies that's controversial is called carbon capture and sequestration. Carbon capture and sequestration is a technology that removes CO2 from the industrial process. Okay. Like a plant. Before it leaves, gets out in the air, it captures it and redirects it. And so it's captured before it escapes into the atmosphere, and then is stored underground. Later, it's used for other industrial uses. For instance, to help create, you sell it to companies that could use that carbon dioxide because it's, fizzes. So extraction pressure in oil fields. Or someone said, I remember someone talking about putting the soda, for that little fizz, like, Vernors. Okay, so there's carbon capture model there where the plant is, and then where they're storing the carbon in a cavern, like a cavernous area down well underground, redirecting it. So the one case, and we'll get this, is when we get to your discussion board for this week, geoengineering. And this is the use of engineering technology to reduce atmospheric carbon dioxide. For instance, sulfur aerosols put into the stratosphere to absorb sunlight, or like a little bit of global dimming, spreading iron particles around the oceans to increase the growth of algae, etc. There's this group called Geoengineering Watch. I saw the website, and some of the science I'm not too sure about, but they say they're looking at what are the particular downsides of that. But and the big question, I'll just give you a hint now with the discussion board, is this what it's going to take to avert a catastrophe? We're too far gone that you're going to have to use some kind of major cross your fingers and hope for the best. Another thing you can do is offsets. Offsets are voluntary payments made to initiatives to reduce the level of greenhouse gases in the atmosphere. They're sold in terms of tons of carbon dioxide, or CO2. Commonly, offsets can be in the form of forest planted or wind energy underwritten. Remember, the Vatican was opting for carbon neutrality by purchasing forests in Hungary, tree planting forests in Hungary to absorb the carbon that the Vatican City was producing. They were trying to be the first, under Pope Benedict, the first carbon neutral, nation state in the world. On the right there is one I did. Like I said, I mentioned native energy and wind farms, well, different places, but including Indian country, which I wanted to see happen. And so you get these certificates. In fact, someone I knew, his daughter had a bat mitzvah, so I got her for a bat mitzvah. I got her a gift of a carbon offsets from Native Energy, and he loved it. And he just kept telling his friends and bragging about that. It was a gift. So there's a big problem, though. And I noticed before, back and forth, and I didn't notice that when I was directing Michigan Interfaith Power and Light. How do you know what they say they're actually offsetting, they're really doing? The quality control, regulation, like that's the devil's in the details. So that's a challenge there. Another is emissions trading. So cap and trade, for instance, the system of buying and selling permits to pollute, So there's a total emissions goal set, which is reduced year by year. And the more polluting companies buy permits to pollute from the better performing companies. So the better performing companies save a lot more money, and so it's economically feasible for the permit. It's beneficial. It's an incentivized for the polluting companies to not have to pay these other companies, and that they can find their own technologies and find ways that they reduce their own pollution at the source. And as you keep dratching down total by total by total years, that makes the difference. In fact, this is what the proposal that happened back in 2009 or so under President Obama tried to do that and didn't go too far in the Senate. But it was used before. Why? Is successfully in addressing the acid rain issue in the early 1990s. Sulfur dioxide. They were able to do this cap and trade. And some countries are doing that. And some now they have markets like the carbon market, or they're so carbon tax and dividend. You tax, this is not in your tax, I don't know why, but this is very big. You tax carbon at the source, and then you provide dividends to lower income folk who would bear more of the burden. So everybody's paying more in carbon use, so other things cost less, relatively speaking. And for the poor people, who have to get transportation, it's bigger bite out of their income, then there's a dividend back. And this is the approach of the Citizens Climate Lobby, which you have their website in your resources this week. It's this what I like about it, and I was active with them for a while. I want to get active with them again, is that they have a strictly bipartisan approach. For every Democrat sponsor, every Democratic person who's a sponsor of legislation, a Republican has to be willing to be a co-sponsor as well. So it's completely bipartisan, and I don't know how many people they have, but it's catching on. And long ways to go before it gets a critical mass, but at the state level as well, that there's some states that are going for this. And of course, there's adaptation. It's a realization that no matter what stabilization strategies we adopt, the sea levels are going to rise, more climate refugees are going to have to be addressed, and the climate is going to be impacted for what crops are now, able to grow where in the future. Climate's changing. And we said last week, because carbon dioxide stays in the atmosphere for so long, unless there's some super geoengineering way to suck that out, we're going to have to adapt to this. And it's a wide-eyed strategy to prepare for those realities. For instance, cities of New York and Miami Beach are already doing that. So that's the end of our discussion. We'll keep coming back to it because climate is like the underpinning of almost every other environmental issue. So it brings, now we're so water, the chapter on waters is about 97.5% of the Earth's water is salt water. It's almost all of it salt water. Fresh water then is a renewable resource. But the problem is that you have overpopulation, especially in certain poor areas, overconsumption, and uneven distribution of fresh water leads to a water crisis. Most of the fresh water that we do have available is frozen and unavailable for us. And in the United States, the fastest growing communities in the West and Southwest are in the areas with least available water. The irony is that here in Michigan, with this class, Madonna University, is we are the most water-rich area. The Great Lakes can constitute 20% of the world's available fresh water. It's in these 5 Great Lakes. As you can see, we are tremendously spoiled. Although I remember a number of years ago when they were talking about the Southwest water drought, they wanted to see whether they could divert the water from the Great Lakes to places like Arizona and New Mexico. And there was a Great Lakes Compact about the governors of the Great Lakes region and Ontario to say, basically, hands off. If you want the fresh water, move back here. So he said the sources are drying up the West, and the two of the biggest your text mentions are the Colorado River and the Ogallala Aquifer. Okay. And we'll talk about those, but the Colorado rivers, along with Northern Carolina, is one of the big sources of the Southwest and Southern California, along with the melt from the Sierra Nevadas. But in the Ogallala Aquifer is basically the Great Plains down to Texas. So let's say more about aquifers. Just some definitional terms. When you see a bold print, keep that in mind because we have a midterm. Just again, the first part of the class is getting some language straight. Okay, definitional terms. But groundwater is when the ground soil is saturated with water, and I go up like the metro parks, and you kind of spongy, get off, and they're like on marshy, almost not quite wetlands, but the area kind of overflow with water. The ground, it's saturated basically, can't hold anymore, and so it starts to pool up, and that part, the top of the part, it's not just the water that's in the soil, but the water that's kind of stays on top. That's the water table. How much water, just pure water, is exposed on top of the ground there. The aquifer then is just a large deposit of groundwater, okay, from a large area. And subsidence is when the aquifers become depleted and the ground begins to sink. You see that in cities around the world, and concern even our areas. So And then saltwater intrusion, and this is that picture on the right is demonstrating this, is when groundwater near coastal areas is overpumped, right? And so it starts, the subsidence starts to come there, but then the salt water then pushes in, it seeps in and fills up that vacuum that was there. You know, like empty cavern, because the water, the groundwater, the fresh groundwater is no more in that area. So there's the misallocation of water is both a human and ecological ecosystem threat. Human water's contamination. 90% of human waste is discarded and untreated, put back in the rivers. But there's also, you know, chemical contamination, pollution, fertilizer, etc. You know, farms, like factory farms. If you go out to I-96, if you're in West Michigan, you can smell it. And we'll get into that when we get concentrated CAFOs, but not only with what it does to animals, poor animals, but it has all this manure and stuff that goes in the water system, and that's why you have these things like, you know, these things like E. coli with spinach, and these big recalls that come to these big farms in California. It gets contaminated water, so it's these farms and industry are washing the soil and the groundwater, and bad bacteria happens because E. coli, etc. And so the depletion of aquifers then dry up the cleansing wetlands and area habitats. Let's see. These are what dams, and so that's what, and this is what dams are doing. Dams alter the flow of rivers, they starve sediment, and they result in released methane gas. And so because you got decaying vegetation, then so there's a lot of issues involved with dams. I mean, people say hydroelectric power on the one hand, the other hand, you know, it's non-CO2, but there's other kinds of impacts on the ecosystem. It's not on the water area. It can be very, very negative. So that you can see the impacts there, downstream impacts. It says there in that little picture on the right: reduced biodiversity, poor water quality, lower crop protection, decreased fish population. Then again, the dam with itself blocked fish migration, disrupted flow of sediments and water, and hazards from aging dams. And then the reservoir behind it contributes to global warming, displaces communities, increases waterborne illnesses, triggers earthquakes. So there you go. When we talk about consumption of water, your text talks about virtual water, or the water footprint, another name for it. This is the quantity of water embedded in food and products, you know, and then manufacture, the packaging and the like. And the higher up the food chain, the greater the water content. For instance, 1 pound of wheat takes 172 gallons of water, while the same pound of beef is 1,500 gallons of virtual water that's embedded in the whole process of feeding. You know, and you think of the life of that cow. This also applies to manufacturing. For instance, the water content of a car is 39,000 gallons of water. More than 1/2 of the water used by industry goes into producing energy. Now, growing uses for irrigating agricultural biofuels, such as corn for ethanol. So while you're trying to say, okay, we're doing corn that use less oil, you know, energy independence, grow our own fuel here, but particularly as opposed to something like switchgrass, corn is very energy intensive, nutrient intensive, and water intensive. Worldwide, agriculture makes up 70% of embedded water use, and this is worldwide. 20% for industry and 10% for domestic use. Now, as your book tells, the U.S. is a little different, and for instance, domestic use is a little bit more, 13%. So what are the things with climate change and water issues? Currently, population and economic growth are the most important factors impacting water issues right now. If you look at what is like water, but by mid-century, it's going to be climate change. As I said, climate is like the substratum for everything that we are probably going to be addressing in some way, shape, or form throughout the rest of the semester. Flooding and droughts, like wildfires, are now increasing as we, California, with the dry there and the winds that happen. It's the worst wildfires in recent years there. In the Himalayas, the receding of glaciers, this is a big one, threatened to dry up the fresh water supply for some of the world's biggest population in Southeast Asia. Even the Ganges River in India, that begins in the Himalaya mountains. Well, as these glaciers are retreating, you're getting less water available for the folk of China and Nepal and India, Pakistan, and some of the most population dense places in the world. In terms of water conservation, on the supply side, text talks about harvesting rainwater. We're going to get in each of these. Desalinizing seawater, and protecting the aquifer that supplies drinking water. Now, how you can get water from new sources, that's supply. Demand is like the energy efficiency side. So low flow, where you use less water, low flow plumbing fixtures, fixing leaks, or recycling water from cooling systems, or in more efficient landscape irrigation practices. So the rest of this chapter, we will get into these in detail. And then needing lower on the food chain, of course. So in terms of residential water conservation, there are both technical measures and we call practice or process measures. So for instance, an example of a technical measure would be a low flow shower head or converting landscapes to efficient irrigation system. And there's an example of a low flow shower head that I bought for $9 from Real Goods back in the 90s, or 2001 or so, around 2000. And that you could shut off the water, just pluck that switch while you're slathering so it's not running continuously. Now, on the other hand, there's behavior changes, such as taking shorter showers. And you'll need educational resources for behavioral measures to last, why. And we'll get into that about fostering sustainable behavior in a little while. It's like, how do you be a social change agent? And a water audit is essential to get a baseline. So you can look at the shower head, annual gallons saved, 2,171 gallons there. And we're in an water audit. If you use a faucet aerator, these are those things you put on the faucet, which I also had, which keeps the pressure going, but there's less water coming through per second or minute, and that saves over 930 gallons. So these things add up over a year, adds up, saving water, saves money. Now, commercial water conservations, there's three types of sites. There's commercial sites that include all kinds of businesses that provide products or services, okay? Think of businesses, large and small. Institutional sites include public facilities such as government buildings, schools, prisons, hospitals, that kind of thing. Madonna, for instance, would be. And then industrial sites that are involved in the manufacturing and processing of products. And the water use in these type of facilities, these either commercial, institutional, or industrial, are bound up with there's a great deal of cooling system that keeps processes cool, and then water is used for that. So there's a water's cooling system, as you can see. Now, domestic water use. The biggest use of domestic water is in the flushing of toilets. So they say solution can be dual flush toilets, or even if you want to get radical, composting toilets, which I know at Leslie Science Center in Ann Arbor they have, where the human waste becomes compost and used in garden, believe it or not. The next biggest use is washing clothes. Now, text notes high efficiency washers use 27 gallons a day, as compared with older washing machines that would use 35 gallons. And you look at, again, we talk about an Energy Star label. You look at that if you go to Lowe's or someplace. And then the third biggest use is in shower heads. And again, we already mentioned taking shorter showers and using low flow shower heads can help address that. Another area is irrigation. Now, in the American West, 70% of residential water may be used to keeping lawns green. So drip irrigation, there you see an example there on the right, which just shows these lines and they drip off, uses 30 to 70% less water than traditional sprinklers. There's also that you look at lawns, how many of them, place like Arizona, where there's, was already mentioned, lawns are you're trying to use something in English that brought up a green grass lawn, which is used in an English countryside, and you try to transplant that with a different climate to the American West or Southwest, just doesn't work. It's too intensive. Or golf courses, for instance. But desalinization, your text talks about two different types of technologies. One is reverse osmosis. Some people have that in their homes too. There can be a microfiltration system where water molecules pass through a membrane, but the salt molecules remain. So in a sense, it captures the salt molecules. That's one area. And then distillation is you boil water to produce steam, and then you catch the water as it condenses. Anytime you go to the store and get distilled water, there you go. And there's a desalination plant, or a model of one, and you see a picture there. Both systems are 3 to 5 times more expensive procedures to produce drinking water than conventional treatments. However, in some places, arid parts of the world, or in seacoasts, it may be worth your while. There's even one in California. So, like I said, both types, reverse osmosis and distillation, are used in arid parts of the world, or also areas abutting the ocean, as the picture shows there. So rainwater harvesting is the system of collecting rainwater before it runs off into the sewers. Now, stormwater, just definition text gives, is water that falls during the rain. And rainwater harvesting is collecting and storing stormwater for later reuse. And what you're going to need for this, you need first, as the text says, a catchment area such as a roof, okay, to catch the water. Then you have to conveyance device such as a gutter or pipes that move it along, and usually that's and then filters and roof washing to remove the debris. A storage in a tank such as a cistern. Then a conveyor system to move the water along, usually using gravity. And then a purification system if some of the water is to be used as potable water. And potable water, all it means is suitable for drinking. So, you look, and a good purification system may use ultraviolet light for that last piece of the element, if that's what you want. If you want to reuse the water, that's rainwater converted to drinking water. Get rid of any toxins or chemicals or other stuff that got caught up. And rainwater endowment basically is the knowledge as to how much rainwater can be captured in an area. Okay, so that's when they use that term. So here's a couple of examples. Rainwater harvesting. You can see this can be, there's a catchment there, there's storage, and then the tank. So you can see how it's moving water in. There can be a sand filter, purification system, or there's another one over there. However, you can have something, not quite all the elements, but as simple as a rain barrel, which I had in my parish in Wyandotte. We had an organic garden, and so we had a rain barrel, and you can see you have bricks or cinders, blocks that it has up there so the gravity can move the water down. We had it tied into a drip line. So drip agriculture along beans, and it came out the gutter. And this one, as you can see, has two. You can connect them. I have several rain barrels. I've had several rain barrels as well in another parish I've been at. but it's the best kind of water for fertilizing because it's rainwater, all the natural minerals. Now another term is gray water reuse. Gray water is wastewater collected from the bathroom sinks, showers, other kitchen sinks and bathtub to reuse as toilet water. And you can see there, that's the IHM Mother House, and they've done a phenomenal renovation green. Fact is, if you want to, one of the people, sustainability leaders, was talking to someone like Daniel Conroy there, is the project manager, as see what they've done, which is phenomenal. But one thing they did with the gray water, they constructed a wetlands in their back, and if you look at that picture, you can see the water in the upper left-hand corner towards there. And that's a pond that was constructed. They have a little windmill that moves that pumps the water along, and it's out of, again, out of their showers and their sinks, and it gets in there, and actually it filtrates it, so it's actually cleaner than it has to be. But then it moves back and using their toilets. They save 6,200 gallons of water use per day just by doing that. I think I heard it's like close to 50%. Back of my mind, I haven't found the exact statistic, but I did find that. So it is phenomenal amount of water savings. Again, remember, toilet flushing is the most intense use of water, and that's why low flow or dual flush toilets are really good, because in fact I had a dual flush toilet when I was in Wyandotte, and you have them at the Franciscan Center in Madonna. They're getting now more important, liquid waste as opposed to solid waste in terms of how much water is going out, being pushed. Wastewater treatment is all the water that runs into the building streams that you don't, after it's been used by industry or residential customers. And now in rural areas, wastewater is diverted into septic tanks where the bacteria breaks down the waste. In urban areas where most folks live, gray water and black water run into the same system. Now the law requires that they be treated before they are released back into the ecosystem. Urban wastewater treatment is at 3 levels. Primary treatment is where solids are removed. The grit is removed by allowing the wastewater to rest in settling basins. Then there's biological process in which the aerobic bacteria break down organic waste and some chemicals and metals. And then there's a final filtering and disinfection process. So 3-tier. And why it's also used in terms of, as an impact in terms of, again, all things are all related. Remember, we're a systems view, not just even though we're talking topic by topic, but over the context. 4% of electricity in the United States, especially if it's from fossil fuel use, is used to pump and treat wastewater. Now, there's a famous issue with wastewater, of course, is when it's not properly treated or properly water system. And the Flint water crisis, when the water is coming from Detroit, but it was switched to save money, so the Flint River. The problem is the older pipes, lead pipes, were very corroded, and that lead got in the water system. As you can see, that's Flint tap water there, supposedly clear, wasn't. And lead levels in residents, which causes brain damage, including children, particularly where they're most sensitive, because their brains are still forming, skyrocketed. And then it's something big, one of the biggest scandals and shameful in Michigan politics. And this is what happens when you have money as the bottom line rather than the consideration of the well-being and the quality of life for your residents. There are, however, in the treatment of wastewater, alternative technologies, which I find very exciting. One is constructed wetland. These are engineered to use natural processes from the communities of plants, soils, and bacteria in wetlands. And as a matter of fact, the city of Mount Clemens at one time had such a system in place. And the wastewater then flows through subsurface gravel where bacterial treatment can happen. Another technology is membrane biological reactors. Now, these are usually oftentimes in commercial building, They're compact constructed wetland processes where bacteria living on membranes break down nutrients. Again, the water going through the membranes, and it gets affected there. And then there's the living machines, which is really, I think his name is John Todd, that started, he was in New England. And these are patented wastewater treatment process where the primary treatment takes place in large tanks. Then the wastewater flows into tanks filled with water hyacinths, cattails, etc. They take up nutrients. Then it flows into gravel. Then into other tanks where it's eaten by zooplankton and snails, where it's eaten by fish. And then into polishing wetlands. So it's several processes that go through all natural processes that make sense, one step to the next step to the next step. And that'd be kind of interesting if someone ever wanted to do a paper about. So for instance, here's a couple of examples. The membrane biological reactors, you can see the membrane bioreactor comes the bacteria eating that, the solids, fecal material, other things, and then the water comes out clean. And then you can see the very complex, the living machine on your right. Now, stormwater. When the land is undisturbed, nature has its way. The system works, The natural processes connecting the water, soil, and living systems work together in a self-sustaining system. Rainwater in this system stays or moves slowly. It gives time for cleansing. It's also a hedge against flooding. When wetlands, though, are replaced by building and roads, there is a significant lack of protection. That's gone in cleansing. Case in point, New Orleans, 2005, Katrina. The wetlands there, which were very abundant, were hindered by a lot of construction, housing construction, other places that had been wetlands. So when the hurricane came in, a lot of the floodwaters, the wetlands were not as effective. They were hampered in terms of absorbing the water. The rest we know. The rest of the story, where the levees broke, so it could no longer act as a buffer. And we see there's New Orleans partly underwater there. Now, a sustainable stormwater strategy would be, in addition to restoration of natural wetlands, then you have infiltration. We have engineering to give water access to the soil by, think small, they say construct for 1 or 2 year storms, just small, regular rain, not the 100 years big ones. Start at the source at multiple locations where the water would pool. So you have all over the place, and maybe lower areas where water could pool. That's where you put in those systems. And you minimize impervious structures. These are water that runs off concrete parking lots or roads. When that happens, they pick up pollutants. For instance, oil, antifreeze, pesticides, and the like. So natural stormwater runoff save money on costly construction. Natural stormwater enables restored habitats to reappear. Crosswinds March, again, when they had to destroy the wetlands, again, I mentioned this earlier, at the Metro Airport, Crosswinds Marsh in Sumter Township was constructed. I think it was like 2 or 3 times as many acres of constructed wetlands, and now there's a great marsh for birds and herons. If people are in that area, can go see it. So here's an example of they're permeable. See the water coming through, and it's absorbed, so it's stored in the ground instead of just running off. And then you have natural ground cover. So the water is more. The water goes in deep. It's as a 25% shallow, 25% deep infiltration, as opposed when you have a lot of impervious cover, where there's only 10% and 5%. And here when you have a permeable stormwater runoff, a natural system, you have 10% runoff as opposed to 55% runoff. So big difference in terms of water conservation. City of Detroit program now with if you haven't nonprofits, churches, anybody with large parking lots in residential have to develop systems, apply these technologies to save on stormwater runoff. So there's another best management practices, BMP, or low impact development. Didn't put the initial there, but LID. One is a rain garden, and you plant depressions in the landscape with native plants to temporarily collect stormwater runoff. It kind of slows it down. It collects the water. It filters it so it doesn't rush after a big rain. It lets it out slowly. A bioswale is a rain garden usually along a roadside. It's a drainage channel with a vegetative surface. So you can see there's the depression there along that road. And because those bioswales are linear, they can transport water from one place in the landscape to another. And again, a swale doesn't necessarily use native plants. Bioswales always do. And native plants are good because they're perennial, because they do absorb the water, and you're not having invasive species there. So you're bringing back what was. We put a rain barrier. I remember at we'll get into green burial later, but at the green cemetery I administer, or the green section at Mount Carmel Cemetery in Wyandotte, and we bordered it with switchgrass and black-eyed Susan and oak trees, all native plants, to say this was our natural boundary, that this was the area where green burial. And residence time. The residence time is the amount of time that water stays in a swell. Now, for bioswale, it's usually between 1 and 4 days, and there's a little formula there on the right. Okay. And of course, we'd be remiss if we didn't talk about porous paving. Now, this is a way to provide surfaces where, I'm just quoting here from the book, where people can walk and vehicles can drive or park while removing stormwater pollutants and allowing rainwater to infiltrate and recharge groundwater. Page 106. The aggregate are coarse particles of rock. It's like sand or gravel. Open graded is aggregate that's all the same size, which can be really good then, open graded. And it's created by placing open graded rock, so 1.5 inches in size usually, and about 18 to 36 inches deep underneath the surface. So you replace that there, the soil or whatever, with that rock. So when the water comes, it goes through there, and it has two functions. It stores the rainwater, so it keeps it stormwater, it kind of blocks it from just, as it slowly infiltrates to the soil below. So you got this paving remember we have this porous paving that goes below then too. And it serves as a bioremediation site where communities of bacteria on the rock can break down petroleum-based pollutants. Here's an example. See how that's below. It goes to the top there, so allow the water to go through, not just run off, and you got those I don't say ridges, cracks. So the water goes through there. It pours. There's openness there, and then below, there's holes so the water can go down, and then it slowly seeps and absorbs down below as well. Finally, we have green roofs. This is a roof consisting of a waterproof layer, growing medium in plants. Often sedum is a plant that's used. It's very hardy. It provides a habitat for birds as well as plants. And green roofs store carbon, they reduce urban heat buildup, and they lower energy consumption. And they save a lot of money. Because you're not paying for all the stormwater stuff, when this Ford Rouge plant was constructed, and they put, or not the plant, but the top, the green roof was put on the Ford Rouge plant, they reduced the cost by $38 million. That's what got young Bill Ford's attention. And it's also it's a great place. People can take tours of the Ford Rouge plant and see the sedum. And it's just environmentally friendly. Birds come and nest there, lay eggs there. It's really incredible experience. People are increasingly do this at homes too, because it does provide some insulation from heat. it reflects off heat, so it keeps reduce your heating bills or air conditioning bills in the summer, and it stores heat in the winter. It's good all the way around, green roofs, and that's something that's becoming more and more popular, and as people are thinking about ways that they can be more environmentally friendly. So, just briefly, the web and video resources this week. There's a video of Blue Gold, World Water Wars. I just recommend really strong, take a look at it. It has what's going on in the world, and even though it's a few years old, it's very good. You can see that it's YouTube. There's 2 websites on water activism for nonprofits: the People's Water Board and the Friends of the Detroit River. There's a website of the Citizens Climate Lobby, which we addressed before. These are the advocates of carbon tax and dividend. Just take a look at it, just to see. The website of the IPCC, the International Governmental Panel on Climate Change. The website of the Catholic Climate Covenant. Again, you don't have to look at these. I just recommend take a look at these, what these look like. And then the website of the American Association for Sustainability in Higher Education. So the video, I'd check, at least peruse that. You can bounce around it. But it's very powerful if you have time. You can watch it, but I would suggest, especially at the end when they look at possible solutions. And then privatization of water. We haven't gotten to that yet. We'll get into that later. That's a big issue. And then discussion board, a changing behavior versus technology to address climate and water. So this is on the next slide. So this week's discussion board. Over the course of last week and this week, we have attempted to address the real problems that the contemporary world faces with the potential disastrous impacts of climate change and the world water crisis. Now, some folk propose that in order to address these problems, we should adopt a lower technological lifestyle to lower our footprint. When I think of this, I think publications such as Mother Earth News embody this kind of approach, this vision. Other folk argue that since technology has gotten us into this mess, human ingenuity and technology is the path to get us out. And perhaps the best people that embody this approach would be the geoengineering people. So is it low tech or high tech? Is it changing behavior, community, or is it changing technology and having faith in that? So the question then this week will be, what approach would you recommend? And why do you think one approach has more possibility than the other in addressing the challenge? Again, there are no right or wrong answers, just fodder for good discussion and critical thinking. Again, your thread had to be posted by Wednesday, and you'll have to the following Monday to answer other people's threads.